Hello.
Hello, good morning.
Okay, good evening. Can you hear me?
Yes, I can hear you.
Okay. Okay. Okay, just okay. So basically, you want to identify the carbon stock, yeah?
Yes, that's what I want to do.
Okay. And you already send me a reference paper. I also already checked the paper about your work. So just a minute. I simply open this paper and
So we can actually use like any other thing except from Sentinel. It doesn't have to be. Let me put on my. Hi, good morning.
Okay. Okay.
Sorry. It doesn't have to be Sentinel. It can be any other satellite. I just kind of shared that person's work because they did the kind of thing that I'm trying to do. I would actually prefer Landsat because I think that Landsat Sentinel does not. My carbon estimation is from 2010 to 2022, and
Okay.
Sentinel does not have data for 2010. So I maybe we should use like Landsat for that, and just so that we can get data from the same satellite. I don't have to switch from Sentinel to Landsat from Sentinel as the year progresses. So I just really sense that for like a framework of the kind of thing I want to do because I've seen that someone have done it before.
Okay.
But mhm.
Okay. Just I simply share my screen, then try to.
Okay, thank you.
Okay, so you can send me this paper. Okay, so basically this paper is that about the remote sensing based model for the tidal marsh aboveground carbon stock. Okay, so in this
Yes.
time they are using here this data set for you can see I will open the flow chart.
Mhm.
Okay.
Yeah.
So this is the flow chart. In this time, they are using here this nave data classification green vegetation. Okay, it is the 1 meter square
Mhm.
data set. They're using the data set, and from this data set, they calculated the fraction vegetation from here. After that, they are also calculated the 30-meter scale average biomass from here, and then also there you can see Landsat vegetation indices. And so take the Sentinel-1 backstruct matrix, and both of dataset they are using for random forest classification. Okay.
Yes.
And you can see they are also used at the average field measured biomass. So do you have any field data about
Yes.
that? Okay, great. Okay.
So I have field biomass for 2016. That's the problem. I don't have for every year. I only have it for 2016.
Okay, okay. So then after random forest model, then they are identify the above ground carbon maps created and model CCAP
Yes.
tidal marsh map and also plan the percentage content okay, and regional level of the carbon.
Yes.
Okay. So in this time,
Yes.
what
Yes.
is your region of interest? Do you have any? Do you have this shape file or boundary shape file about this area?
About the data set, yes, I have it.
Okay, okay, okay. So they are also using the Landsat 8 data in Google Earth Engine platform. Pixel from the Landsat 5TM sensor, type 7 ATM plus 8.
Yes.
Okay, so they are using all of the things. And then biomass values from float located in the same Landsat pixel footprint or urban interface attribute reflectance. They calculated this dynamic vegetation. Savi index, they are also calculated. Okay. Okay, so all of the things we can easily do in the Google Earth Engine platform. There's no problem. They are also take the region, which region they want to come, and also take the field data. You can see they are also get the field data in here, and also put here this name data set. Okay, this data set is also available in Google Earth Engine platform, and Sentinel-1 is also available. Landsat, all of the Landsat data is also available in Google Earth Engine platform. There is no problem. So first of all, we have to import your region of interest. So what is your region of interest? It is any boundary area. We have this boundary shape file.
Yes, I have the boundary shapefile. There are two study area. One is in
Okay. You can just
yeah,
simply send me this boundary shape file. Then I hope it will be easy way. I can import the shape file and then also make all of the step by step. I can easily work for all of the data set. We can easily
okay.
take, and after that we can easily implement the random forest. All of the equation we can easily implement in Google Earth Engine platform. There is no problem. But Savi index or WDRPI5, okay, all of the things we can easily do. Wide dynamic range
Okay.
resolution index. Also, we can say Sentinel
So
one.
does it mean that
Yeah.
does
Yeah.
it mean that we can even for the years that we don't have the data, can we, I told you that I'm trying to estimate between 2010, 2013, 2016, 2019, 2022. Does it mean that we can still estimate even for years that we don't have the data?
Okay, so basically Sentinel one, I think it also be available for the 2015.
No,
Okay.
yeah, I'm saying that, I'm talking about field data now.
Yeah. So Landsat and Sentinel, when you want to use Landsat, we can get the broad range. That is no problem. But Sentinel one is the limited. Okay, so it only for the 2015 we can observe. So what is your time frame for your research?
In fact, I'm already late. Right now, I just have to put it down in the next 2 weeks. Latest.
Okay, latest. Okay, that is no problem. We can easily get the latest satellite image in here. There is no problem in Google Earth Engine platform. All of the Landsat,
Well, what
Sentinel.
I'm saying, I don't know if you understand my question. You remember I said that I only have data, a few data for 2016.
Okay, 2016.
Yes, and that's the only data that I have. I've gone everywhere to look for data. I have talked to people to look for field data because the place is not accessible, right? It's a wetland, so it's not accessible. I went to the place, I couldn't access it. So,
Okay.
but
Okay.
I'm trying to get the. I got data from people who have done work in that place in the past. Field that I've gone there to collect data from the field. I don't have enough resources to. If I have to go there, I have to get like a canoe and pay somebody to do. I don't have that resources, so I went to people that have worked there in the past to get their field data, but I only got for 2016.
Okay, only for the year of 2016. Yeah.
Yes, yes.
Okay. So it's also available, possible in here. There is no problem. So just we can identify the carbon year of 2016 for your region using the same method. Yeah.
Mhm.
Okay.
Yeah, but there's no way we can calibrate with 2016. There's no way.
Okay. So you also need to calibrate it also. Yeah.
What?
So you also need to check the accuracy.
Yeah, I need to check the accuracy.
Okay.
Definitely.
Okay.
I'm saying that the only year I have, I need to take data from because I'm comparing those years. I'm comparing, it's like a time series. I'm comparing
Okay.
the
So
changes
do we have
between
this?
those
Do
years.
we have this the ground truth data for year of 2016?
Yes.
Okay, then we can easily do it. There is no problem. So we can also
Okay.
use the ground truth data for 2016 and also make the all of the using this method. We can also make this model in Google Earth Engine platform. Then we can also compare what is the validation, what is the accuracy both of data set. Then we can easily identify what is the accuracy of the data. That is no problem.
What I'm saying is that I'm not sure you understand. I'm saying that with 2016, can we get estimates for other years?
Yeah, we can also estimate the other year. Just you need to change the time. Okay, or time you want to simply change the time, then you can easily also get the for other years the data set for the carbon stock.
Okay.
Because in
So
Google,
how much is it going to cost me?
in Google Earth Engine platform, we can easily identify, we can easily change the time period or time boundary, and we can easily get the result. Okay, so just I simply
Okay, even with just 1 year of field data, right?
Yeah.
Okay. So how much is it going to cost me?
Okay, first of all, you can simply send me your region of interest. Okay, your boundary shape file. Okay, just I simply share
Okay,
with
I will send it
my.
to you today. Once I drop my daughter, I will sit down somewhere and I will send it to you.
Okay, I simply send my email. You can simply put this all of the things in this email. Okay. So in this email, you can simply put all of the things. Then I hope it is better. You
Okay.
can easily get this result.
Okay. 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 I've seen your email. I will send it to you once I settle down now.
Okay, you can simply send me.
Mm-hmm. Oh my God. It's almost like okay.
Did you send me this?
No, I'm coming. I'm trying to send it now. I
Okay.
have to check my.
Okay. Okay. And it is situated in the United States.
Yes, it's situated in the United
Okay,
States.
there is no problem because only for the National Agriculture Imagery Program, this dataset is only available for the US. So when you want to
Okay.
use this, you must be in your institution or in your location. It must be in here in this region. Otherwise,
Yeah.
we did not get use the dataset. And this resolution is only for the 0.6 meter resolution, very high resolution.
Okay. Yeah, I'm coming. So Okay, I've sent it now. You will see it in a minute. I'm see, I'm talking to someone. I'm talking, right?
I did not get.
Did you see it?
Not.
Yeah, it's taking a while. It came from my other email. Have you seen it yet?
I did not get it. Okay, okay, get it.
Okay.
Let's simply download. Oh my god, you have this the KMZ file, yeah, not shape file.
No, oh yeah, I have the KMZ file. You want the shim file instead?
Yeah, yeah, I can use it better, but when I need the shape file, okay. So do you have this shape file, or I can easily convert the KMZ to shape file. There is no problem.
Okay. Okay.
Okay, I convert it just. In online, we can easily import the KMZ file, and automatically it will be converted to the shape file. Then we can simply use the shape file in Google Earth. So we try to make the only for one region. So suppose I want to use this.
No, it's one region, but it's two area.
Okay, okay. So first of all, you can try to work with for this first area, then take it.
Did you see that there's Wax Lake Delta and there's Barataria Bay.
Okay.
But I can bring you. I can send it when I get to school. I can send you like the shape file and the TIFF file as well.
Okay. Then I can see it now. Download. Okay. Starting the laptop. And your time is that year of 2016.
What did you say?
What is the time? Year of 2016.
Is it me? I'm looking for 2010, 20. I'm looking for 2010, 2013, 2016, 2022, and 2019. 5 years.
Okay. So we do have 2002. Okay. There is no problem. We can easily get the data set because this data set will be start from 2002. You can easily change it. So In this time, I can simply take the 2016, then we also try to change it. There is no. So I simply try to
Okay.
run the model using the randomly one year, then try to check for the other year.
Okay.
Take the whole time period, time, and already installed area. This is the and from this, in this time, using you can see in this paper, they are use this NAIP data set for making calculating the fraction vegetation. Okay, so from this data set, they are calculating the fraction vegetation. So in this time, I use the data set and then try to make the first of all, I need to calculate it the vegetation. After calculating the vegetation, I need to make the fractional vegetation. And what's the equation they are using for the calculating the fractional vegetation in this paper? Just let's find out the equation.
They are using the NIR.
So fractional green vegetation in landscape pixel they are also calculated. Here for each region, we generate 1 meter resolution map of tidal marsh green vegetation, non-vegetation, and open water, which has used calculated 30-meter fractional cover green vegetation per landscape pixel in the blue carbon element map. Okay, so they are also calculated this name data set, also calculated the landscape imagery also. First we try to make the init for 90 pi. Then I simply get this bound. Okay. They already provide the band in here. You can see all of the necessary band. We need to only for the near infrared band and also need to the green band, red band. Okay, because our formula is that for NDVI, near minus red divided by near plus red. We can simply implement this. Okay. Okay. So in this time, in this image, I can simply select this and then I simply take a variable. First of all, I simply put the variable suppose near and call my image and select the specific band. The specific band is that near infrared band. You can see band name is that. In this time, near infrared band name is the N. Okay, so I simply use that the N. Because this band name is N. N for near infrared. Take the another variable, suppose red. Variable I simply put select the band for red. And red band is that R. Okay. I simply take a variable. Suppose this variable name is the NDPI. And then I simply put the equation such as here. It subtract with red band and divide it here and with red. This is our formula. In this time I just try to show the result. F dot here. All the ending. Okay, so you can get the error. This is that okay. In this time I want to check how many images I want to get. Okay. So for the year of 2016, how many images I want to collect. I simply the print function, then call the image, then the size. Click the run. So now it's computing how many images I have to get. You can see there is the 0 image, right? time, table near all the data set I check as near improvement. Take another variable check how many data set by a lot of things. Okay, so in this time, I not for the lot of things. I need only for my event which I uploaded. I need the image only for this thing. So I simply pounds with simple is the ROI. Now I can calculate. Okay, for this region, I can get only for the 7 images. Okay, so in this time for the 7 images, okay, so I'll use at the 2006 and check how many images. Okay, you can see 2016 there is a no image available. When I want to increasing the year 17, we can get to the 17. Only for, I think only for the 1 year. Only for the 1 year. Okay, so it also available. 2017 is also available, but 2016 there is the no image. Suppose I also check the 2018 how many images available. 18. Yeah, I can see 2018 there is a no image. So we can check it 2020. There is a no image. 2020.
What about 2020? Oh, 2022. Okay.
There is a no image. 2020.
What about 2022?
There is a no image. There is the image. So year of 2015 you can get. So 2016 there is a no image. I think you also need to select your time period according to these images. How when the image is available or not. Yeah, it also available when I want to use at the 2017. It also available for this. 7 images.
Okay. What about 2010?
2010 you can check. 10. Okay, 7 images is available. Yeah.
Okay, so which years are available? We have 2010, 2015.
2015 I can check. 2015 there is a no image. For this
There's a noise.
2015, okay, 2015 is available. 2015, 2010. And what's the next time?
So which one again? What about 2020?
2020, I think that is a noise. There is a no image.
So we only have 2 years available.
Yeah. Okay, so you can first of all you can try to use the model then suppose 2010. Then you also change the time period, or I think it also available for suppose 2020. We can use at the 19 from 2020. We can get the total years. Wow. Okay, then you can see also.
Okay.
So 2019 to to 2020, we can get the images. But
Okay, so we have 2010, 2015, 2019, right?
Yeah. Then it also possible we can get the satellite images.
Yeah, what can we check it for? Maybe 2021 to 2022.
2021 from and from take it also. Yeah, no, that is the noise.
What about 2022 to 2023?
That is the noise.
Oh no. Okay. What about 2020 to 2022?
2020. That is the noise.
There's none. So we can't get for 2022 at all.
Yeah. Okay, so you can
But
try
we
to
can get.
so you can also try to make this time frame according to this data set, because you need to must be use the data set when you want to make this paper. Okay, so you can use that the 20 available. Seven. Yeah. In this time,
But I have another data set from me that is in my Excel file that we can use for 2022.
yeah.
I have one, yes, is on my Excel file.
So this file is available for this time for satellite image.
What did you say?
So in this time, you have to choose your time period according to this image. Okay. Suppose you can see 2015 is available, so you can include in your research and add the year of 2015. Okay. 2010.
Can I have 2010, 2015, 2019?
Yeah, it's also possible. There is no problem. Yeah.
Yeah, and for 2022, I have me personally in my inbox, in my computer. I have a data set for 2022.
Okay, then you can if you have this data set, then you can easily import it the data set in Google Earth Engine platform, and you can also make this analysis. There is no problem. Okay? Your data set must be use the TIFF format.
Okay.
So now I can simply select this and put the equation of the NDVI near rate and by with here and with now and this is the result. For that, for using this use the total 7 images, you also need to make the reducer. So in this time, I take the total 7 images average pixel value. I simply use that the mean result. Okay. Now it will be take the 7 images average pixel value and also click with the shape file in RY. Okay. So now we can take the run. Painting this line. Now I think it also display. Also need to focus the center of the shape file. And the map dot center of the RY. I can see it calculated this area. So we can calculate the NDVI. Okay, so I'll set the color parameter, then it will be better. Color I can see minus -1, next up to +1. Set the color blended and make the list of the color. For the list, I have added this water body such as blue color. Then up to what I have used the white color, and up to dense design to show the green color and blue color. So I think there is a no build up area. Yeah.
Yes. This is
Okay,
open my shop.
if you want to check the value from here, so as I simply inspected, I click on here. For the water, we can get the negative result, negative
Mm-hmm.
pixel value, and for the vegetation, we can get the positive pixel. Okay.
Mm-hmm.
Okay, so this is the one part for calculating the NDVI using the data set. Okay, so then next
Mm-hmm.
part we also need to use here. So you can see. Okay, so in this time we also need to calculate the 30-meter data set for the land set. 30-meter data set we need to use and then try to calculate it the map. Okay, and from this map we also need to calculate the fractional vegetation. Okay, so let's go. So
Mm-hmm.
for that, for this reason we also need to import the boundary. So I simply okay. So what are the sentences they are using? Take it. Okay, then they are also training the sample. They are take for the 150 random point. Randomly they can point, and then they are make this analysis. They are using the Lancet 8 images. Okay, so I just simply import it. The user the Lancet 8 OLI. They simply get this variables. Right? Yes, variable. And then filter for its shape is that are I per date. That is x as a 0 in December 31. Then I also set here the filter here is that for the number over less than and all of the images created the in flip the shape by what is that ROI. Meantime, I also need to calculate the NDVI or calculate the NDVI expression in the chart. Chart right, right, here, here plus right. Here this chart is that the image with the band is that here for the band I think band 5. near. And first we can use the band 5 and wait for the band 4. Just I set the band 5 for rate. Okay. So now I'm reaching the result. That later. I have to set here this color gradient. Now I can get the two data set for NDVI. Okay, so this time take the next one. Just okay, and they are also used the total 150 random point to ease the region. And they are also used Sentinel one data for okay in this time period. By Copernicus access okay the polarized data will give you one. Gradient the hectare. They are also confused. Okay, so next step we need to use the serial one also, serial one data. So for that I simply imported the serial one data also here. And from the serial one data they are only using the band. Okay, they also calculated the remote sensing variable. You can see two band vegetation, PB, PI, also wide dynamic range vegetation. They're using this, and also calculated the soil adjusted vegetation. Survey index are also used. And there also you can see Sentinel one, three band start dataset that are used at the PH PB mean packet scatter coefficient in green segment of the landscape pixel. Also PI's and DV the packet scatter standard deviation. Calculate the standard deviation in green segment of the landscape pixel. Also PS and DV packet scatter coefficient of the variation in the green segment of the landscape pixel. They're calculating. And there also you can see National Agriculture Imagery Program. They are used for this calculate the fractional green vegetation in the landscape pixel. Okay. This time we simply imported that. Okay. You can also get the data of 2015. You can see. Just I simply rotate that dataset. Bound. Why? It. Okay. Total